Okay, this is great. Today is another special day. And every new class is always better than the previous class. And I believe today what we have to do on the list is unique. And we just have to give it our best and see how we'll be able to, get value out of what we have to share today. AWS has what is called well-architected framework. And without you knowing what the well-architected framework is all about, you'll not be able to add value to the organization. It will be difficult for anyone to add value to any client anywhere. And now this well-architected framework has the 6 pillars. These are the stanchions that AWS, a well-architected framework of AWS is hinged on. That these pillars are what is carrying them, and it's good we become very much familiar with them so we'll be able to turn out a well-informed architecture for our clients and for our organizations. So in this phase, we would have to look at the pillars step by step and see how they relate to what we do as cloud engineers, as DevOps engineers, as solutions architects, and as SysOps and developers. So we'll look at them comprehensively, starting with it now, talking about the well-architected framework. To get it introduced, you would know that creating a software is just like you constructing an edifice. So you would have to put in certain knowledge in demonstration, which would start off with the initiating, and you go in digging deeper to want to understand what is the buyer or the client or the sponsor's objective, what are they looking at achieving, and you would do that and carry out some feasibility studies to see if it's achievable, and if it's achievable, what are you going to do according to the competing constraints like cost, like risk, like quality, and so on and so forth, the resources which you have on ground. So that would make your foundation solid for your structural. So once you have this done, you know that your building is going to have good integrity, and technology-wise is the same. And that is what Amazon is offering clients around the world. And when we look at them, you would understand that if we can hit that for our clients, we can say that we've really added value to their business. So we need to look at them, not neglecting them. And the first thing we would have to understand is that there is operational excellence. Operational excellence is one of them, one of the 6 pillars. And the next one is security. You want to come up with a system that would be difficult for anyone to pillage. The marauders may not be able to break in if you have it well built, considering security, and something that is reliable. So reliability is part of the 6 pillars there. We have performance efficiency, we have cost optimization, and sustainability. So, but to get things done in this area can be a little more challenging. But if we have them in mind and come up with strategy of achieving them, you will see that seamlessly we will turn out products to our customers that will cut down on their costs. Okay, we'll turn out products that can encourage them to stay in business, compete, and then obtain a higher market share. So the AWS well-architected framework helps cloud architects to build the most secure and high-performing, resilient and efficient infrastructure that is possible in time. Okay, so this framework would supply a kind of consistent approach for customers and AWS partners to evaluate their architecture and provide leadership in implementation and implementing their designs. So, and yes, of course, we would know that considering scalability is always there. Scalability saves them time, saves them money. So we would always have this in the back of our mind as we come up with the design. So let's see the very first pillar as we introduce operational excellence. Operational excellence, what does it mean? Yeah, now this entails the ability to support development and run workload effectively, and also to obtain insight into their operation. And through this, we would be able to have continuous improvement that is supporting the process and procedures to deliver business value. So operational excellence here now is saying that it's quality, zero defect. And also we're going to integrate continuous improvement. We are coming in with fit for purpose. You understand? So by tweaking our processes that we have on ground to ensure that we keep obtaining value for money increasingly. So then when we talk about the design principles that we have to consider, there is 5 spectrum that we would be evaluating operational excellence in the cloud. The very first one is perform operations as code. What is perform operations as code? We're talking about automating operational tasks by using code and automation tools. Okay. The next one is make frequent, small, and reversible changes. That is continuous improvement. All right. Why reversible changes? Reversible changes, if peradventure the required value is not being obtained, you know that there should be reverse engineering. You have to take things back to where you picked them from. So then number 3 is for you to refine the operations procedures frequently, make it better, refine it. You look at it with your team and see how you can cut down on waste and make it top notch, add some innovations to it. And you have to anticipate failure also, because without you designing to failure, designing to want to be able to accommodate failure, you have not started designing. So it's good you anticipate failure, that it is possible for this beautiful edifice which I have made to break down. If it breaks down, what will be my plan B? What is my backup? Would my data still be safe? Would I still be in business? So that is risk management principles, okay, which you would have to envisage failure even before they approach you. You identify anything possible. And also always learn for operational failure. When the emergence of failure, you should be able to come out with knowledge. Your worst should be that you learn something, how to make it work, how not to do it. Okay, then the best practices, your operation teams need to understand their business and the customer needs. What are we in business for? What are we trying to achieve? And what is the customer's need? So when you have to identify the customer's needs, when you identify the customer, how do you identify the customer's needs? You identify the customer's need through the business needs. Okay. And then your own operational team should be conversant with their own business also, and to find a middle ground on how to integrate this. Customers needs rather is very important, and you, without knowing what the customer needs, you will not be able to satisfy them, because in this area we are talking about customer satisfaction, and what you're turning out would have to satisfy the customer. And that's why we're saying fit for purpose. What we're designing must be fit for purpose. That is how we achieve operational excellence. So let's advance to see number 2. Now, number 2 is security. Okay, you have to protect your data. There must be protection of the systems. Okay, there are certain other functionality and services that we can take advantage of in the cloud technologically. So we must be conversant with them. And one of it is the encryption at rest, encryption in transit, and so on and so forth, that we have been training on. So we have to be conversant with all these things and know that, okay, this is how I protect it. We may want to use policies to create a class and ensuring that it's only selected few that must know certain things are preview to them, needs for, yeah, that's that. So then what is the design principles? I want you to know that for you to achieve a good security, you should be conversant with 7 things. Okay, you have to have a very robust, concretized identity foundation. You want to know who is on board, who is doing what, who has done what. Then you enable traceability. If peradventure something goes wrong or right, you should be able to probe down by conducting some root cause analysis to an assignable cause, knowing that this is what caused what just happened. It may be cost overshoot. What is that functionality that is making us to spend so much? Do we really, when you know that you may want to do functional analysis, do we really need it? Do we need to save our data in multi-AZs or not? No, you not do that. Then you apply security at all layers of your architecture. You automate security best practices. When you identify certain processes, you have to ensure that it's been automated. When the operators in the systems are asleep, the system should be able to protect itself. And you're required, as part of the security rules around the world, to protect data in transit and data at rest. Ensure that where you have your data, people do not have access to them.
Hello, Timex.
Yes.
Please, I just got you a time. Can you confirm so that the meeting won't hang again?
All right. Okay, thank you very much. I would check now and then get back to you on that. So that is about that. You have to prepare for security events. This is one of the things that you must do, okay? Or else you have not started security on your project. Okay, data confirmed. So you've not started security. So now let's take a look at the best practice. So now everything you design must follow this line. It must have an aspect of these 6 pillars for you to say you have a well-architected framework. It must follow the 6 pillars in a way. And when you want to discuss the architecture of it as the solutions architect of your organization, this is where you start your talk from. This is how you now start thinking of adding value to your consulting organization. Because certain times, the challenge which they face may not be away from these 6 pillars we are talking about. If you have a good understanding of it, you should be able to navigate your way in a kind of direction that you will help them to save cost, or if that is what they want. But the customer will tell you what is their problem. And you may look at it and advise, okay, let's go up. So, right. All right, best practice. You have to put in place practices that influence security. You will want to control who can do what. Always know that not everybody should be able to do everything. AWS calls it least privilege. Don't feed a man with access more than his pay grade. That is least privilege. What the manager should be able to control should not be same with what the supervisors under him can control. And the foremen and the engineers under the supervisors too should have some limited access, some restricted access to certain things. Okay. So you have to protect your systems and your services and maintain the confidentiality and integrity of data through data protection. And everything about security should be well defined. Yeah. I'm going to, before I move on and continue with 3, I want to take a feedback from somebody before we move on. If my projection is clear there, and if you are getting any value before we continue with the class. So we want to go.
Yeah, Timesh, everything is fine.
So what have you
It's
learned?
clear. So far, I'm learning about the is it AWS well architected framework? We talk about the performance or the first one, the first principle. Then we talk about security. The security is where like I got interested because I've already learned about this in cybersecurity a bit. So I think the knowledge is still here. Like you can transfer whatever you learn from somewhere else to another domain, which is good.
Okay, now in cybersecurity, did you learn, is it the PCI DSS on security you learned, or?
No, about the principles of like data protection, where we talk about data in transit, confidentiality, integrity, availability, and all those things.
Okay. Yeah.
Yeah.
That is
So I
that.
think like as cloud engineers in the making, we also need to learn about security, because if you provision the infrastructures and you don't know how to protect them, then you are going to be you find yourself wanting. So I think it's good that we also try to get the foundational knowledge in cybersecurity, like the ISC2. I don't know whether you heard of the ISC2 certified cybersecurity. Is free. I took the
Yes.
exam in March, and I was able to certify in March. So it's a good starting place for us to also consider.
Okay. Thank you very much for that advice. It's good to learn security. You're right about that, because you must secure everything you provision. You must. So who else?
Yes, Times. I'm here. This is Eric.
Okay, good to hear your voice.
Yeah, so I think this actually this is my first time of hearing about the AWS well architected framework. And the first one that you talk about was the performance. Because as a solution architect or a cloud practitioner, if you are employed, you must make sure that what all your service, they are, they have to perform to a certain level, because you are delivering the content to the end user or the customers. So you have to make sure that everything that you are doing, you have to make sure that your organization stay top of what delivering content to the end user or to the general public. Because you wouldn't want a situation whereby maybe during the day at a peak time, let me put it this way, at a peak time, then your service will be going down, or you will find yourself wanting, as in maybe your servers are going down and then you need to know what to do. So you have to, put your house in order, you have to put things in order so that you deliver what seamless content to the end user.
Yeah.
And then the second one, which you talk about, was the security. You have to be because you are dealing with, how do you call it? Let's say the application that, your company is running, people have to log in with their credentials, password, and then maybe let's say it's a startup or a fintech, like financial company.
Okay.
So people trust you with their data. So as a solution architect or a cloud practitioner, you always have to be security conscious, because should anything go wrong, people's data will be leaked to the public, and let's say the middleman will get access to all those things, and then we all know what happens when people get, the middleman gets access to credentials. So you have to be very, very security conscious. You must put in the best security practices so that you protect customers' interests and then their data, and not only the customers' data, your organizations too. They also have, you have to protect their integrity, and then you have to protect their data too. So you always have to be security conscious in everything that you do as a cloud engineer or as a solution architect. Security must come first. Yeah, so that's what I want to add. Thank you.
Thank you very much for three of you that had to make this contribution. I'm grateful. So we would continue with what you guys have shared with us. We'll develop further from there. It looks very good for every one of us to pitch in with our prerequisite knowledge, because this is how we grow ourselves. Okay, when we all contribute and share, we grow the next man, and then we grow our own self. So number 3 is the reliability. Reliability is another form of quality, and you have to know that the workload must be performed correctly, must function correctly and consistently, and when it's expected to. It's just like whenever you call on the function, it has to perform. Okay, so throughout the total life cycle of it, you should be able to operate it and without causing a downtime, and carry out some tests immediately also. So we would get this done by designing according to 5 principles in the cloud. The first one is to automatically recover from failure. The system should be able to automatically recover from failure. And that's why certain times we want to include the backups, we want to include the snapshots and so on and so forth. We'll talk about it when we talk about ARCHITRECTED and Aurora and the Elastic Cache. We would be able to share on that. So these are how they work. So you should be able to automatically recover from failure and test recovery procedures, and should be able to scale horizontally to increase aggregate workload availability. You have to stop guessing capacity. When we guess capacity, we are saying that, okay, we are making a forecast of our system. Yeah, we can manually make a forecast, and that forecast may not be as anticipated. So we really want you to have it automated. That is why you were taught the elastic load balancers. Using the elastic load balancers, creating the auto-scaling group, and so on and so forth. So you will not guess if the system is, because certain time you may think that this and this would be the expected workload within so and so time, and it may triple. All right, if it triples, what happens? You should consider that. And you have to manage change in automation. Yeah, and the best practice before building any system, foundational requirements that actually influence the reliability should be in place. Foundational requirements about that. For example, you must have sufficient network bandwidth to your data center. You understand? Sufficient. Now, something just happened that is informing us wisely. We started, all of a sudden, I ran out of data. I had to get something that was not enough, but yet we are using it. But we had already recorded downtime. Downtime is money. And you want to guide against downtime in your system as you design, as cloud engineers. So performance efficiency. Now, it must have the ability to use computing resources efficiently to meet systems requirements. As demands are changing and technology is evolving, your system should be able to perform efficiently. Now, there are certain times we would build a system that cannot be integrated with other open source systems. If we tie them to certain things, you discover that our own system will now start slowing down. That is to say that we did not consider other innovations, other technology as we build it. We should build it in a way that we can, if peradventure something is being obscured, something is no longer invoked, an aspect of our system is no longer invoked, we can cannibalize it immediately and replace it with something more recent as so invoked. So get this done by considering these 5 things. Democratize advanced technology. What is democratize advanced technology? When we say democracy, we're talking about the government that is made for the people, right? So we are saying that you have to ensure that the technology which you have is accessible and available to a broader or more diverse range of people. You don't only want to design for secluded class. Even if it's a premium product you're designing, you should be able to accommodate whoever that has the money to pay. And your system should be able to go global in a minute. And it should be able to use serverless architectures. And your engineers should be able to experiment, all right, play with some things in there to see if they can make it better. What are we saying here? The system should be able to conduct value analysis. To see if the functionalities are adding value to the performing organization or the sponsoring organization. And there's what is called mechanical sympathy. You must consider it. Mechanical sympathy is you developing a deep understanding of how the hardware works, and using that understanding to write code that takes full advantage of the hardware's capability. You need to know that, all right? Have all this in place, and okay, you need to be conversant. Now we're talking about scale up, but virtualization must be tied on the physical server, right? There must be a capacity of the physical server. And anything that you're designing should be aware of the capacity of the physical, the touchable server. So if you're coming up with code, your code would also consider the full capability of your hardware's best practice. Have the mindset, guide yourself with data-driven approach. With that, you should be able to come up with statistics on what works and what should work in the nearest future and inform your design. So for everything you do, there should be records. You should be able to gather data in all aspects of your architecture. So you can come back to review your data by looking at the choices which you have made in past to say, okay, are they adding value? All right? You have to ensure you are aware of any deviance from expected performance. You don't want to be taken unaware. Here we go. We have cost optimization. You want to run a system that will deliver business value at the lowest price. That is, you want to obtain more for less. If the system scales, if the system is able to virtualize, what do you think that is? That is cost optimization, using one single physical server to run thousands of servers. To get this right, know these 5 things. 1, implement cloud financial management. Adopt a consumption model. Now we're talking business. When we say consumption model, what is taking what? This is about cost segmentation. This is about cost segregation. This is about understanding the cost structure to say that what is making us to spend this much? What is taking what? Yes, okay, at the level of lump sum, we could be spending $30,000. What is taking what? And that may want to lead you to another level of the Pareto principles, the 80-20 principles, because you must be conversant with it, knowing that 20% of your activities will lead to 80% of the total cost your organization would face. Always. 20% of all your activities, just as small as 20% of your activities control 80% of your organizational cost. So you may want to identify those 20% and see how you can cut down on them. If you can take care of this 20% and reduce it, you have taken care of 80% of the total cost that your organization may incur in time. So you want to major on the major. You want to identify the majors and major on them. You don't want to major on the minor. And there are other 80% activities that can only amount to 20% of the total cost of organization. This is how you perform your cost structure as a procurement engineer. This is how you perform your cost structure as a cost engineer. You have to stop. Another one is measure overall efficiency. When you have these things, this functionality segmented, you will now know what is bringing what value to the system. And certain times we have negative value bringers and positive value bringers. You may have a range of 10 functionality or applications on your system. Then you discover there's only 20% that are giving you 99% of the value which you have. The remaining 80% are taking out, are feasting on the value that the other 80% are bringing, other 20% are bringing. So what do you want to do? You want to truncate them. You want to eradicate them from the systems and ensure that you only have the fine players instead of giving them loads to bear. Stop spending money on indifferentiated heavy lifting. Analyze and attribute expenditure. All right. So best practices as to other pillars, we would say there are trade-offs to consider, right? When we say trade-off, give and take. That's to say that if you're reducing one year, that one may be appreciating. But for example, do you want to optimize for speed to market or for cost? What is speed to market? You're coming up with a product, an application that you feel will serve the people, but you're still scared of competitors coming out with same application. And you look at your in-house engineers, if they take them 6 months to get that done, which is not good at all, and you want to cut it down, what would you do? You may want to, invest more money to hire more engineers. That is how we do the trade-off when we come up with speed to market on our product. So in some cases, it's best to optimize for speed. The organization may say, this is, let me put it, use the right professional term. Time is of the essence. Time is of the essence project, which means they are ready, willing to spend as much as the project will cost them just to hit the market or finish the product, finish designing or building the product on time. That is time of the essence. So you will define what they want. Going to the market quickly can actually save you certain times, millions of dollars. Because when you ship new features, before the competitors would know, you had already taken over. But we may want to also invest in upfront. Let's buy some things now that we know if the market is going up, things may be expensive in the future. So let's make some investment now, spend more money now. So when things had gone high and as others are coming in, we are ready. At that time, we will be using from our old stock and we will just be saving money because we will not be buying until the market will stabilize. So that's on the cost optimization aspect. So you do the trade-off to ensure that you have all this being balanced. Finally, sustainability. You have to consider the environment. Triple constraints, okay? Triple constraints. Not triple constraints. Triple constraint. All right. Okay, every sustainability. Now I was taking you to professional heights, okay, in a different way, but let's soft pedal. Okay, every sustainability is hinged. Okay, 3 pillars of sustainability. Yeah, that is the right word. And sustainability, you see, before you can define sustainability, you must consider sustainability on 3 pillars. The first one, you have to consider the environment. You don't want to jeopardize the environment because you want to make money. You don't want to start planting mass in places that the rays are going to be going out will be affecting the local community and the people that are living in there. You don't want to be extracting oil from the ground and be jeopardizing the environment. Can you see that? Second one is the economic. You still would have to consider the financial aspect of your design. How much would it cost you? Then the other one is the societal impact of your business activities. So for you to design a sustainable product, understand your impact. Who's going to be affected? And how would the person be affected? What is going to be affected? And how would it be affected? Come up with sustainable goals. Maximize your utilization. Anticipate and adopt new, more efficient hardware and software offerings. Use managed services. Again, you see why AWS is thriving? Because certain times they want to let buyers know that they have managed services. When they say serverless, they're not telling that there's no server, but AWS manages the server. Reduce the downstream impact of your cloud workloads. Now, for every supply chain, we have the supply chain being segmented in a way we have the upstream and the downstreams. The manufacturer is in between. You, the cloud engineer, the solutions architect, you form the manufacturer, you stay in between. Where do you get your raw materials? The upstreams, right? So you don't want to go to a place and get a kind of raw materials that after manufacturing it, the downstream will be impacted. Those people that are being affected, that are using it, will be negatively affected. Your cost, your profit will be affected. You don't want to do that. So you consider sustainability. Best practices. You choose AWS regions where you will implement workload based on your business requirement and sustainability goals. The cloud front built for us for the edge locations should be selected. You don't want to somersault over an edge location that is around where you're in your region, or maybe an availability zone that is close to you, to want to go and start doing things in a far availability zone. You know, that is like you are encouraging low latency. So you use Your user behavior patterns can help you identify improvements to meet sustainability goals. So try to see how you can scale infrastructure down when not needed, how you should be able to scale them all up when needed. All right. Okay. From what we've done so far, if we call it a day, would it be that we have done wrongly? The 6 pillars.
I think we've covered enough. This alone, when we want to go through it, to take us another 1 hour, like on our own. So I think it's good.
Yeah, we would have to stop it here. Because what I have today, I shared it. What I really wanted us to do actually today, I wanted us to look at database and analysis, which we talked about. Let's see our design. I've added more to it. You can see it. If you can see it, this aspect, database and analytics, we have the relational database, we have the Aurora, we have the Elastic Cache, we have the DynamoDB, we have the Redshift, we have the AWS Glue, Neptune, Etina, Elasticsearch, and Kinesis. Okay, so you can see that it's about 10 of them. I just wanted us to maybe go as low down to somewhere like Elastic Cache. But I wouldn't want us to be so much loaded and at the end of the day, we are feeling helpless. So let's say this is a day, all right? Tomorrow, we will start with the relational database, okay? Take it easy. I know some would say, but we've not done anything now. We've just been doing theoretical aspect of it. When we look at this relational database, you will see how we would feature the 6 pillars of AWS well-architected framework, considering them from cradle to cradle. Yeah. Okay, I'm going to stop the sharing and then we would stop the recording.
Timex.
Yeah.
Sorry,
Go ahead.
Is it not better for us to maybe treat like let's tackle this the other percent like tomorrow, then we'll do the practical aspect of it, maybe theoretical aspect for today, then tomorrow we'll do the practical aspect of it. Well, we'll still have a lot of time.
Yeah, it sounds nice. Maybe we can introduce just 3 aspects or 3 of the stuffs there, and then tomorrow we just come in and do answer, right? All right.
Sure.
Is that for all? Is that for all? Should we go ahead and maybe just introduce, because that will not take us more than another 15 minutes. Or if you are tired and you want to say, let's call it a day.
Yeah, you can go ahead.
We can go ahead, all right? Okay, let's see.
Well, you can go ahead.
Okay, we have the screen shared. All right, my dear friend Ben, I think is in this class, but today he's not featuring with his full name, Benjamin. He's coming in with Ben. Benny, are you there? If you're there, just wave your hands. Let's see if you're there, or just say, yo. Are you there? Okay, Ben could be in a place where he doesn't want to talk. All right. So we got a screen shared. We have to move on now to the next stuff, which we have database and analytics. We're gonna do just 3 things, and we end here. Like you are conversant, database is what we've been hearing, and we all know what database is. But I wouldn't want to assume that great Benny, great, good to know that you're here. You're welcome back from vacation. All right. So I want somebody to tell us, share with us his or our understanding of database. Database. Kindly, okay, let me see if somebody's raising his hands. Augustine, you can kindly unmute and share with us, Augustine.
Yes.
The way you just called my name
I
is
think
like...
you went mute for a moment. So what you were saying?
I said, okay, just share with us.
Yeah, you were saying something, but I think you were mute.
Okay, I'm repeating it. I'm repeating it now.
About the database.
Yeah, I said Augustine
Okay.
should tell us what he knows about just database, like the colloquial meaning of the word, of the compound words database.
Okay. Sure. So typically the database to a layman is like the storage for our resources that we share to the customers or to the end users, where we keep our resources and the information of the users, if I'll put it that way.
Okay. Yeah. Like the fisherman that I am, we may not be able to have some things as well defined the way you would love it to be defined. Like what I would say, it's a bank where we keep data, right? Is that too ordinary for your degree level? Pardon me if that is...
It's okay.
All right, thank you very much for pardon. Oh, Sopro wants to blast you, want to dissect it. Go ahead, Sopro. Sopro, is it that you saw your hands up and you immediately
Just to
removed it?
add. No. I'm coming to answer. Just to add to what he said. You see, yeah, database, as the name suggests, because he said the layman understanding of the database. It's simply, as he said, is a place or a container. It could be a container. It could be a store where we pack or we make available the information or the logics of a particular company or a particular organization or everything that has to do with organization, which they would not want to make available to the public space because of its sensitivities and stuff. It could be relational and it could be non-relational. Relational in the sense that relational simply means the way it is structured. Like it is structured maybe in columns, rows, and in such a way that you can easily go there and fetch the information and then use it for your analysis and stuff. Non-relational is that maybe it can be the information stored in that particular area or that particular bucket or that particular container is scattered. When you go there, there is no particular format in which the informations are being gathered over there. So these are my understanding of what database is all about.
Oh, Saburo, thank you very much. You added some spices to it, and you did very well. Thank you. All right. Before we now start talking about it, we would pick up from what Sapuru said. But at the end of the day, from everybody, we have agreed that this is where a bank where we keep data. It could be a box, it could be a container, it could be anything, even in our back pockets. Somewhere we keep data. And Sapuru now went further to tell us that it could be relational. All right. And he said it could be in columns or rows. Now I'm going to take us a little bit down to my level of assimilating things before I pick them up, which is number one. You have a box. If you want to travel from South Africa, Augustine wants to move from South Africa to Manchester, and he went into his wardrobe and I start dropping clothes on the bed, drop them, and that's okay. I'm going to pick these clothes and put them in this box. If Augustine packs everything there and dump it in the box and zip up, it's not relational. But if Augustine will say, okay, all right, let me now fold the boxers in a kind of unique way and keep them in a segmented place, pick my pants, fold them, and keep them in a particular edge, and have my t-shirts somewhere close to the boxers, and my beautiful white singlets should be at the middle, then I'm going to keep my toiletries and the deodorants in a particular corner. Can you see that Augustine had been able to define them in a way, in columns, maybe in, we may say in rows, in positioning. So once you get to that angle, you know you're gonna be finding shirts in a particular place. When you get to this other place, you're gonna be finding, so that becomes relational. Jabai, is this too local for you? Jabai, are you with us? Jabai, please wake up. It's just 9 in Nigeria. Don't sleep by Jabai. All right, let's move on to see certain other. Now we have the understanding of database. We've been able to set the foundation. So let's move on to see some kind of databases that AWS has to offer us. So the first one on our list is the relational database. Okay, it's like a web service that makes it easy or easier to set up, operate, and scale a relational database in the AWS cloud. And AWS is in charge of the management of this service. And it uses SQL as the query language. It allows you to create a database in the cloud that are managed, like I said, repetitively managed by AWS. And now we have types of AWS, types of engine that are managed by AWS. Please, somebody should give me an affirmation if I'm audible where you are.
Very well.
All right.
Yes, you are.
So the very first one is the Postgres. We have the MySQL, we have the MariaDB, we have the Oracle, we have the Microsoft SQL Server, we have the Aurora, which is a proprietary database that AWS has. All right. So this order could be like databases in the open source, but AWS is coming up with some strategies on how to have them integrated with its system and still manage them. And the RDS that AWS provides can create backups and can patch softwares. It can detect automatic failure and also recover. That is cloud security, right? When we say patching in the cyber world or in the cloud world, we say now there is an identification of some issues, security challenges, but immediately those loopholes can be patched. All right. So that is that. So you can turn on automated backups with the, or we will look at it. You can manually create your own backup snapshots. All right. You can also get a high availability with a primary instance and synchronize it with a secondary instance that you can fail over to when problems occur. So you can also help control who can access it. All right, now that is bringing us to our IAM, identity and access management. To do so, you have to use identity and access management. Beautiful, that do I know? Wow, so you have to define users and give certain permissions. It can also help protect your database by putting them in a virtual private cloud. Whoosh. Okay, you can keep them in a place in the virtual private cloud and have your NACO as a security firewall to protect them. Can you see that if you have a database in the PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL, you can also communicate with your organization to want to patronize Amazon, and Amazon can help you to feature all these which we've talked about. The next thing in line is the other services. Automated provision, OS patching, continuous backup and backups, and restore to specific timestamp. That is point-in-time restoration. Whoosh, this is so powerful. I love this so much. Certain times we do it in our computer system and we do not get what we want. What does it mean? Peradventure, there is an advent of challenge in your system and you want to go back in time and say, can you restore 5 minutes ago? Can you restore 20 minutes ago, 3 days ago? You see now? So you can use it and be provisioning going 5 minutes, 10 minutes further and backward to know where the system was before the challenge. Yeah. Before the challenge. It's so unique. It's so unique. RDS is so unique. I bet you we are going professional as solutions architect, knowing all these things. Okay? And you can also monitor the dashboard. It creates what is called the read replicas for improved read performance. Yesterday in the group, I shared read replica with us. There's a write-up which I dropped there in the group. All right? And that is real-time restoration. Thank you, Ben. So now I want somebody to quickly go there. If you have not read it, if you have read it, just share with us what you understand by read replica. If you have not, you can quickly go to the Telegram group, our group, and go just skim through and be fast and then share with us. You can read it verbatim as we are here and explain to us what you understand. Because I know that we would still want to talk about it today. That's why I beforehand dropped it there so you could have gone to assimilate it and get yourself ready for today's class. So let's see who want to take us there and read and just share with us what you think it's all about.
You said we should read verbatim.
If you like, just do 1 or 2, 3, 4, 5 lines and explain just on the very first part and explain the little that you can to us. So for those that did not read, they can say,
let me try something.
All right.
So when we talk about, let's look at the replica first. The replica is just like a copy of something. So we are talking about database replica, the read replica, right? So this is like a copy of the original database. So this is what I want to say. That is kept or somewhere that in case there is a problem with the original, you can fall on it, if I'm right.
Okay, you're saying if you're right. You're asking us if you're right. That sounds nice. I wanted to say, when you were taking it, do you know what came into my mind? I wanted to say, is it all you have to say about this whole matter that happened today? Is it all? Just this little? Certain times, that's what my wife will say. Is it just all? Please say some more. Say something. But I've just said something now. Is this not enough? All right. That is beautiful. I appreciate it. Thank you. It's nice. So without understanding, let's take one more person and go. When we do things like this, we understand it better. Okay, let's take one more person. Go through the same statement and explain to us in a different way. Okay, is nobody going?
Yeah,
Yeah, hello, teammates.
Okay.
yeah, let me explain. Hello? Yeah, okay. What I understood from the reading simply means a copy of database that is the same thing with the original, and there is another the original database, but this is a separate copy, but it's the same thing with the original one. So that's starting from the reading.
Sincerely, I've seen somebody do that. My network is better than the person's network. But we heard you clearly. So that's about that, okay?
Okay.
You got it right. We heard you because we can just look at your eyes and can see what you had in your mind. All right, let's move on. Now we have this understanding. Read replicas for improved read performance. Okay, like replica. Replica is a device that replicates, or a replication. That is just it. But now it's saying read, which means you may not be able to do so much, provision it, play with it, remove and modify. You may not be able to do that, but you can just view it, So multi-AZ setup for for disaster recovery rather. So AWS can offer that. It can also create a maintenance windows for upgrade. It scales either vertically or horizontally. It can save with using elastic block storage, but though it doesn't SSH. All right. So automatically it can modify storage if the free storage is less than 10%. You see, of allocated storage. If the last storage lasts at least 5 minutes, sorry, if low storage lasts at least 5 minutes, it can actually modify. And if, since the last time you modify is 6 hours is the last time you modify, it can modify. When you have an application that has unpredicted workload, you never can tell how it will be. You're expecting 10,000, but at the same time, you see that it may be 40,000, but other analysis would say that it's 3,000, 2,000. So RDS becomes your option. Please, I wanted us to continue, but let's kindly stop here, okay? I have been working during the day, and tomorrow I'm still going to be on transit for a longer time. Please, let's just stop here for today. Please, you people should show some sympathy. Okay.
Sure. Yes.
Please, thank you very much.
Okay.
I'm going to stop the sharing and stop
You're
the record.
welcome.
And can't you see that I'm a good man? I have to plead with you people to stop the class.